So rational exponential expressions. So if you have 2 cubed times 2 to the 5th, we're just going to be simplifying these, so I'm not going to actually put this in my calculator and write out a number. I'm just using numbers in this case before I use exponents. So 2 to the 3rd means that I have 2 times 2 times 2. 2 to the 5th means I have 5 more. I'm just going to put parentheses so that you can see where they came from. So 2 to the 5th, I have 1, 2, 3, 4, 5. So then if I want to simplify this, I want to write just 1, 2, 1 base of a 2, and then just write a single exponential, or a single exponent. So I have 3 and 5, so 1, 2, 3, 4, 5, 6, 7, 8. So I actually have 8 2's multiplying, or 2 to the 8th power. Okay, let's do one with variables, and we're going to write out a rule in just a second. So x squared times x to the 4th. So again, you have x times x, and then you have x times x times x times x. So in total, you have 1, 2, 3, 4, 5, 6. So you have x to the 6th. That's the simplified form. I can't do anything else with it. Yes, this one you could actually give a number, but we're just going to leave it, especially if it says just simplify. So the multiplication rule. Oops, I picked up the wrong guy. Multiplication, sorry, had to sound that out. Rule. So if you have x to the a times x to the b, the a and the b just mean any exponent. All you have to do in the end is take x and then add a and b. So if everything is multiplying, notice it's multiplying between those two, you just add a plus b. Isn't that what we did? What's 2 plus 4? 6. 3 plus 5 is 8. If you have a highlighter, this would be a good thing to highlight right there. Okay. Now, if we have x to the negative 2 times x to the 10th, so when you have x to the negative 2 or any negative power, I'm going to use a number again just to show you. So if I do 2 to the negative 2 power, notice it gives you 0.25. It's actually 1/4. So 0.25 is 1/4. So all a negative exponent does is it flip. Oops, sorry, that was loud. Is it flips it to the bottom or changes it to a denominator. So you would. I always do it like this. So I write it as a fraction, and this moves to the bottom. So it'd actually be x to the 10th divided by x squared. So then x to the 10th is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over x times x. Now if you look at those, and I'm just going to cancel those out, because if you have x divided by x or 4 divided by 4, any number divided by itself is just 1, so it cancels out. So I'm actually left with 1, 2, 3, 4, 5, 6, 7, 8. So it would be, my answer would be x to the 8th. Now, if we follow this same rule here, since it's negative 2 times, or x to the negative 2 times x to the 10th, you can just do negative 2 plus 10, which equals 8, and that would be your exponent. Okay, let's do another one. If I have b to the 4th divided by b to the 6th, it would be, I could rewrite it as b divided by b, that's 4, 5, 6. Cancel out. it would be 1 over, because there's nothing left up here, so we just say 1, divided by b, and since there's 2 of them, it'd be b squared. Or, since we just talked about what a negative exponent does, you could write it as b to the negative 2. Anytime it's on bottom, if you want it on top, you just write it as b to the negative 2. So then our next rule is called the division rule. So if you have xa divided by x to the b, all you have to do is x a minus b. That's the division rule. Okay, the next one's pretty easy. If you have 4 to the 0 power, that means there's 0 of them. Now, you don't want to write it as 0. 4 to the 0 power is 1. 2,000 to the 0 power is 1. 5, 4, whatever, raised to the 0 power is 1. Any number raised to a 0 power is 1. So if I wrote it as x to the 0 power times b squared, x to the 0 power is 1, times b squared, so the answer would just be b squared. Okay, this is the 0 exponent rule. X to the 0 equals 1. And just make sure x cannot equal 0. If you put in 0 to the 0, it gives you an error. Okay, so that's the next rule. Okay, I forgot to write a rule up here. So if you have room, if not, just put it where you do have room. So a negative exponent. So if you have x to the a, negative a, sorry, then that equals 1 divided by x to the a. Just put that wherever you have room. So negative exponent x to the negative a equals 1 divided by x to the a. It just flips it or changes that information to the denominator and takes away the negative. Okay, last rule, we have one more. If I have x to the 4th, y squared, and all of that is squared. So x to the 4th times y squared squared. Since this information is inside of a parentheses, this squared is saying all of this is squared. Now it's not the same as multiplication up here, because that's like saying there's 2 of those parentheses. So we actually have x to the 4th, y, and then for this parentheses, x to the 4th, y. So you actually have 1, 2, 3, 4, 5, 6, 7, 8 x's, and then 1, 2, 3, 4 y's. So that would be your answer. Sorry, that got crooked. Okay. We're going to do one more example before we do write the rule out. So it would be if we have x to the negative 2, y squared cubed. So we actually have 3 of these parentheses, so it'd be x to the negative 2, y squared, x to the negative 2, y squared, and x to the negative 2, y squared. So 1, 2, 3, 4, 5, 6 x's, but they're all negative. and then y, 1, 2, 3, 4, 5, 6. So this is called the power base rule. So power base rule, if you have x to the a to the b, so some exponent or some information with an exponent raised to another power. If you notice, 4 times 2 is 8, 2 times 2 is 4, negative 2 times 3 is negative 6, 2 times 3 is 6. So all we were doing in this case is a times b. So if you just have to multiply whatever this is to that power. So that's our last